Hello everyone. We shall discuss about normal to the surface. What a normal to the surface mean? In general, we know that phi of xyz is equal to constant represents an equation of the surface. So if this is a surface, phi of xyz is equal to constant, and if p and q are any two points on the surface, say the position vector of p is some vector r and position vector of q is say r plus dr. According to triangle law of addition, the length pq will be dr. Differentiating phi, we get dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz. This is nothing but d phi. In other words, or it's also called as differential of phi. In other words, the RHS can be rewritten as dr dot gradient of phi, because dr is dx I cap plus dy j cap plus dz k cap dot grad phi or gradient phi is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. So when I consider the dot product of these two, we get dr dot grad phi, which is equal to dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz, which is equal to 0. So we know dot product of two vectors a dot b is magnitude of a into magnitude of b cos theta. The dot product becomes 0 when the two vectors are perpendicular or orthogonal to each other. So in other words, magnitude of dr into magnitude of grad phi cos theta is equal to 0. This happens only if cos theta is equal to 0. In other words, theta is 90 degrees. So it's very much clear from the figure that grad phi or gradient phi or del phi is perpendicular to dr. So vector grad phi, which is the same as del phi, is called normal vector to the surface since it is perpendicular to dr. Unit normal vector is denoted by n cap. So gradient phi geometrically interprets normal to the surface. So if gradient of phi is the normal vector to the surface, how do I find unit normal vector? How do I find unit normal vector to the surface? Vector by its magnitude gives us the unit vector. So we already know gradient phi, the output is always a vector by its magnitude. This gives us the unit normal vector. So this is how we evaluate the unit normal vector. Note, the angle between the two normals to the surfaces phi 1 and phi 2 is cos theta is equal to n1 cap dot n2 cap, where n1 cap is the unit normal to the first surface and n2 cap is the unit normal to the second surface. So let us look at an example. Calculate the unit normal vector at the point minus 1 1 for the function 2yz plus xz plus xy. This is a scalar function phi. So we know how to find the gradient of phi. So gradient of phi is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. So when we differentiate this partially with respect to x, y and z are treated constants. So this will be 0 when we differentiate partially with respect to x. So we get z plus y as the first term into I cap. Differentiating these with respect to y, we get 2z plus x. This is treated as a x and z are treated as constants when differentiating partially with respect to y. So differentiating this with respect to y becomes 0. Then differentiating this with partially with respect to z, we get 2y plus x into k cap. So these two x and y are treated as constants, so this becomes 0 when we differentiate partially with respect to z. At the given point minus 1 1, gradient of phi becomes 2i cap plus j cap plus k cap. Magnitude of gradient of phi is square root of 2 square plus 1 square plus 1 square, which is root 6. And finally the unit normal vector is gradient of phi by its magnitude. So 2i cap plus j cap plus k cap divided by root 6 will be the unit normal vector to the given surface. Let us look at another example. Find the angle between the two surfaces. So you have two surfaces. Let me take it as phi 1. Let me take this as phi 2. They've asked for the angle between the two surfaces at the point 2 minus 1 2. So phi 1 is taken as the first surface, phi 2 is the second surface. Gradient of phi 1. Gradient of phi 1 will be, as usual, dou phi by dou x. In other words, dou phi 1 by dou x I cap plus dou phi 1 by dou y j cap plus dou phi 1 by dou z k cap. So when we find out the gradient of phi 1, we get a vector 2x I cap plus 2y j cap plus 2z k cap, because derivative of x square is 2x, derivative of y square with respect to y is 2y, derivative of z square with respect to z is 2z. Similarly, gradient of phi 2 is evaluated. Derivative of x square is 2x again with respect to x, derivative of y square with respect to y is 2y, derivative of z with respect to z, this becomes minus 1 into k cap. So once we find gradient of phi 1 and gradient of phi 2, find out the values at the point 2 minus 1 2. We get gradient of phi 1 as 4i cap minus 2j cap plus 4k cap. Gradient of phi 2 is 4i cap minus 2j cap minus k cap. So as we already know, to find the angle between the two normals to the surfaces, cos theta is equal to gradient of phi 1 dot gradient of phi 2 divided by gradient of magnitude of grad phi 1 into magnitude of grad phi 2. So very much similar to finding out the angle between two vectors. Vector A dot vector B divided by magnitude of vector A into magnitude of vector B. So where A is gradient of phi 1, which is a vector, B is gradient of phi 2, which is another vector. So we have already found gradient of phi 1 and gradient of phi 2. Consider a dot product of these two. So we get 4 into 4, 16 plus 4 minus 4. So plus 4 minus 4 gets cancelled. 16 divided by square root of magnitude of the gradient of phi 1 will be 16 plus 4 plus 16, which gives you 36 into square root of magnitude of gradient of phi 2, 16 plus 4 plus 1. So we get root 36 for this, root 21 for this. The numerator will be 16. So we get 16 divided by root 36 into root 21 plus 4 and minus 4 gets cancelled out. So we get, when we simplify 16 by root 36 into root 21, we know root 36 is 6, root 21. This will be 8 by 3 root 21. Cos theta will be 8 by 3 root 21. Theta will be cos inverse of 8 by 3 root 21, which will be 54.41 degrees. This is how we find out the angle between the two surfaces or angle between the normals to the surfaces. Thank you.